So this is a popularly voted question to find the critical points of the question and to classify them. Right, so to find where are the stationary points, essentially, where are the stationary points, and find whether they're maximum, minimum, or saddle point. Okay, so we'll work through this and see how this works. So it's pretty standard to start with. To find critical points, or AKA stationary points, we want to find, let's write this a little bit better. Oops. 2017 to 18, question 1. Okay, so to find the critical points, we want to, in single variable calculus, we're setting the first derivative of f with respect to x to 0. But with multivariable calculus, we want to set both the derivative of f with respect to x and y to 0. Okay, so we'll do part A. We want, or let's say for the critical points, it should satisfy df dx equals to 0 and df dy equals to 0. So it should satisfy this, which means if I differentiate f with x, then I get 2x plus essentially this. So I need to solve this equals to 0, and I need to differentiate with respect to y. The first term is independent of y, so that goes away. I just need to differentiate this with respect to y. That is just for my simplicity. I'll expand this out first, because remember, in differentiation, it's better to expand things out. For most of maths, it's better to factorize things. For differentiation and integration, it's better to expand things out. So minus 4y plus 3. Right, now it's easy to differentiate. With respect to y, the x is just treated as a constant, so that should just stay in front. Now we have 2y minus 4. Okay, 0. Okay, so we need to solve for these simultaneous equations. So now you can use your favorite method of substitution or elimination or whatever to solve for these simultaneous equations equals to 0. But if I stare at this, I think it is relatively easy to see. So you could just, at this point, you can jump into your favorite method of solving simultaneous equation. But I can now see, for example, in equation 2, it tells me either x is 0. If I need equation 2 to be satisfied, right? So critical points need to satisfy both 1 and 2 at the same time, right? So 1 and 2 at the same time. If I ever want any hope for equation 2 to satisfy, either x is 0 or 2y minus 4 is 0. So y equals to 2, essentially, either this or this. Okay, so if x is 0, that means equation 1 will imply 3y minus 3 times y minus 1 equals to 0, which tells me either y is 3 or y is 1, right? So either of these cases. In fact, now I have 2 of the answers already, because I need both equation 1 and 2 to satisfy. So one option is x equals to 2. Oops. Yeah, so one option is xy equals to 0, 3, or another option is xy equals to 0, 1, right? But I have another option is y equals to 2. So let's see what equation 1 implies. So equation 1 now implies if equation 2 implies that either this or this, right? So now I'll plug this back into here. So I get 2x plus, excuse me. So 2, so minus 1. 1. So that means, excuse me, 2x minus 3 equals 0. That means I get one unique solution for x, 3 over 2. Okay, so either of these options will work. So you can double check with your favorite method of simultaneous equations. They should get the same thing. 2. Okay, all right, so I have my 3 critical points. Okay, so that's done. So I've calculated the values. Oh, be careful at each of the question. This is not what the question is asking. So always be careful when you read the question, check that you have actually answered the question. Calculate the value of f. So I actually need f of these 3 points, right? So that's not too difficult. So f of 0, 3 is, if I plug it back into f, then I get, let's try to look at both at the same time, 0 plus 3 times 3, well, 3 minus 3, and 3 minus 1, this is 0. All right, so f is 0. If I plug in 01, this is 0, and I can tell this is 0 already, so the second term will be 0. And finally, if I plug in 3 over 2 and 2, so I have 3 over 2 squared plus 3 times 2 times 2 minus 3, so that's minus 1 and 1. Okay. So I have 9 over 4 minus 6. So 6 is 20. So what is that over 4? 24. And does that look right? Let me just check my algebra. Oh, of course, sorry. That's not supposed to be 2. That's 3 over 2. That's an x over there, over here. Okay, so that should be 3, yeah, so 9 over 4 plus 9 or minus 9 over 2. Okay, so 9 over, so basically that's basically I multiply 2 and 2 on top and bottom, right? So that is basically 9 minus 18 on top, right? Just to be, oops, just to have the presentation cleaner. Right, so this is minus 9 over 4. Okay, so these are the 3 values of f.